Hello to all. Today in this video we are going to do an analysis on a flat piece of mild steel. Uh, so we have to design it. First of all, we are taking Solidworks software and we are taking part assembly, part, and in order to sketch it, we are going to select one plane. Now it's loading actually, and we are sketching it in the right plane, and now we are going to draw a rectangle of 100 to 50. We are dimensioning it now. As you can see that now the sketch is fully constrained, and now we are leaving the sketch and now we are extruding it. Extrude boss up to a length of 600 mm, and now it's over. Now it's okay. As you can see that now we have made a 15 by 100 by 600 piece of mild steel, and now we need to export it into Ansys software in order for the analysis. So we have to save it as a particular type of file. It is better for Ansys, so we are going to name it beam, and we need to change the type of the file, and we need to make it into either a SAT file or a IGS or SAT file. As you can see, we are converting it into IGS, and we are saving it. Okay for all bodies, and it's saved right now. Then we can close it actually. Okay, and now into the important part. Ansys is a software used to analyze different kind of simulations. We can see that this is my Ansys software. It is 2019 version R3. It may take some time to load. Okay, in this software we are doing an analysis on this flat piece of metal, and we are going to give a load at the end surface, and we are going to analyze what are its deflections and what are the stress created. As you can see that there is so many types of analysis systems in this Ansys software. It have explicit dynamics, steady state thermal, static structural, transient thermal, transient structural, and we are mainly using the static structure because our piece is fixed, and not because mainly our piece is fixed, because the load is about in a straight line graph, that is linear model. That's why so we are going to, in order for starting it, we need to drag it down, and we need to create a project schematics. We can simply start it and drag it and create a standalone. Okay, now we are creating a static structural drop down. So in this we can see that it is a list of 7 things, that is static structural engineering, data, geometry, model, setup, solutions, and results. We are going from higher to bottom level. In order to complete it, we need to do it in accordance with the order of that. So first of all, we are taking the engineering data. One thing to say is that we can make any type of things we can connect two engineering data together. We can connect two geometry together. So we are going into engineering data. It is from where the material properties are selected. We can see all type of materials are available here. If any type of material is not available, we can add a new material. By adding a new material is meant that we can make a new material with all the properties we are given. So engineering data, yeah, you can see in the engineering data source that we have all type of material, fluid material, additive materials, geomechanical materials, everything is there. You can see the below all the list of the materials: grey cast and magnesium alloy, polythene, silicon advanced additive manufacturing materials such as steel, inconel, Ta6Al4V. Everything is available here, and we can, in the side chart you can see that we are all the properties are given, all the properties graphs are given. According to this, we can plot the graphs and give the properties into the material and add the material accordingly. So every type of material is available. Yeah, you can see the graphs and all here. Temperature properties, Young's modulus, Poisson's ratio, bulk modulus, shear modulus and all. So you need to have a basic knowledge in all of that. So that is the engineering data sources, and now we are going to project. So we have selected the milestone, automatically it is assigned to that. So next is the geometry option. In the geometry option, as you can see that as we completed the engineering data, it get ticked on, so that means it is complete. And after that we are going into geometry, and we are going to right click it and going to import the geometry. For importing the geometry only, I worked in Solidworks and designed it. Either we can create the model, in this case space claim geometry, as you can see here, or in the design model software. These are basically inbuilt 3D building softwares and all. Here we can see I am selecting the beam as it is an IGS file, and we are opening it, so that also get ticked on. Next is the model icon, and in this we are doing the majority of things, and in this is where we are giving the boundary conditions and the setup things and all. And boundary conditions, I mean the constraints and the loads given. So I clicked it, and it get visible right now. So as you can see, we can this is my Ryzen 5000 series. That's why it the actual time taken also depends upon the processor you're using and the graphics card of the PC. Mine is actually a 4 GB graphics card, GeForce GTX. Okay, now we can see that this is the mechanical solver. In this we can see that our 3D model is loaded, and similarly we can see the outline left side of it. Yeah, and this also it is a list in which we need to follow it from top to bottom as same as possible. So while taking the geometry, we can see the details of the geometry, what bounding box and all, everything is given below, and the properties also given below. Everything is given. This is about the geometry. The next thing is the materials, and from here we can also select 2 kinds of materials or 3 kinds, and we can basically do an analysis of that also. So we are giving a material assignment right here for assigning the material. So by clicking the material assignment, we get details of material assignment. So in that there is yellow color showing geometry and material name. By clicking the geometry, it is not selected. In order for selecting that, we are clicking the body. Yeah, you can see the green above that. You need to select the body. Yeah, by clicking it, it becomes green, and now we are going to apply it. Yeah, after applying it becomes red, and after that the material name should be selected. In the material name, I am going to select low carbon steel, that is basically mild steel. You can also change the material. The warnings are also showed that you can either take it. So after my material assignment is given, you can see the coordinate systems and all, x, y, z axis and all, and how it is shown. Now is the mesh. So you can see that by mesh it means that we are dividing the whole geometry into small geometries, small pieces, small pieces. This basically doing like integration and all. We are dividing it into infinitesimals. That means small pieces. For in that small pieces we are applying the equations and conditions in order to generate the solutions for that. So basically as small as the bounding bows, as small as the mesh size becomes, it becomes more and more efficient answer. But at a particular threshold, as we further increase down the mesh size, there will not be any change. This is known as mesh convergence. So we are importing a mesh size onto this. So we need to right click it and to provide a mesh size. Actually it is taking a little long. So talking about mesh, it is a very important thing. In this type of Ansys, I can only go up to 1 mm of mesh size. Below than that it does not work. It also depends upon the processing time also. Yeah, we are inserting a sizing. It is called mesh sizing. In this also we need to select the geometry, and we are applying the geometry by clicking apply, and we are changing the default element size into 2 mm. So by clicking that, our element size becomes 2 mm, and we are clearing out of the drop box. Yeah, now it's 2 mm. And now is the next thing is the static structural option. In this we are giving the boundary conditions. So in order for giving the boundary conditions, I am going to insert. As you can see that there is so many types of boundary conditions right here: acceleration, standard earth gravity, rotation velocity, rotation acceleration, pressure, force, remote force, ball bearing load, thermal condition, fixed support, everything is here. We need to select what are we trying to give. Apart from this, any types of things are not available in this particular static structure, will be available in other systems and all. So in order for analysis we need a fixed for this particular phase we need a fixed support. So we are clicking upon that. That means that we are fixing at one particular phase in all direction. It can be in all either to a direction or in 3 direction. We are applying it in one particular direction. We are fixing it that surface. We are applying the geometry and the type we fixed support. Yeah, as you can see that it becomes dark blue upon that one side where it is fixed support. Yeah, it is purple, I think so. Okay, now we need to provide a force. As you can see, I need to apply the force on the other side, and we are applying that geometry. But by applying that, we can see that as we give the magnitude of about 1000 newtons, you can see that it is defined by a vector. That means it is directly perpendicular to the perpendicular or normal to the surface. But we need the force to be the downwards direction. Yeah, this is in the normal to the surface we have selected, but we need it to be in the direction, which is tangential direction, it is downward. So we need to define it by components. So components basically means that we are dividing the force into three components, that is x direction, y direction, z direction. So in this, every direction need to be 0 except y axis, and it needs to be 1000. But if we give 1000 in this particular direction, it will be upwards, but we don't need it to be upwards, we need to be downwards. So we are giving it negative 1000. So that's all for the static structure. When now we are going into the solution side of it. In the solution side, it is shown so many things, that is deformation, strain, stress, energy, linear stress, stress tool, and that is all kind of probes and all. So while taking deformation, we are taking total deformation, that is one strength. We need to talk a little more about this deformation and strain, stress and all. Why we are actually doing this, the true purpose of it. So we are selecting the total deformation. That means that when we give a particular load of 1000 Newton, how it's going to be reflected upon the dimensional quality of the mild steel. And now we are importing stress also, equivalent von Mises stress. Okay, now some of you can see some are ticked and some are in a solve option. Yeah, now we are solving it. So it gets shown meshing. The first it's done, it is becoming done in the top to bottom order. So as you can see that by doing this, we can see the stress values and the deformation values. So why we are doing the stress value is that, as you can see, when it's get meshed, you can see the meshed small icons. Okay, we can zoom it and we can see that 2 mm is the maximum size of the mesh. Yeah. And that is done. So now in the window we can see that the material is actually deformed. So we can, in this side we can see that it creates a total maximum stress of 182 megapascals. So by what the 182 megapascal mean is that if the stress becomes greater than that of the ultimate stress of the material, it is failed. In case of mild steel, it is about 260 megapascals and all. So we can currently say that it is not failed, but it also depends upon the also depends upon the factor of safety we are giving. If we are giving it the factor of safety of 2 and all, it is failed right now. And now you can see the deformation right here. It is 12 mm. That means when we give a force, it will give 2 mm of 12 mm of deformation. We can put the animation right on and we can see it being deformed. So you can also change in the scale of it also, and the color indicates where it becomes deformed more. So now we can see where the stresses are developed. As you can see, when we push down a member, the topmost and the bottommost will be first of all there will be tensile force in the top side, and there will be compressive forces in the below side, and that is the stress values and all. And we can change the display style into wire shaded exterior, and we can shade into wireframe and all. Yeah, we can also see the cross section also in this. So we take it into the home, and we can also print the report. We can see the report. The report gets automatically generated in this. It is for the documentation purposes. Yeah, as you can see that the report gets generated in this. The all values are given. Gives the material geometry, the volume, the mass, the bounding boxes, the material properties, everything. The stress, the strain, the center moment of inertia, everything, the element number of elements, the nodes, everything is given in this report preview. This is what we basically submit in a assignment and all. So we are getting the message static structural and the results and all below, and this is the load graph. All the type of graphs are given, the material properties, everything. So this is basically the report preview, and we can also print this preview, and by it we can download it. And we are closing it. We are going to the geometry again. So basically the analysis is done right here. This is the meshed. So that is the completion of this. From this we can change the boundary conditions, everything, and we need to put the. So where did I calculate the load and all? That is actually by means of the conditions that in the real case scenario, if I am hanging or if I am standing upon it, if 1,000 kilo bag is put upon the end surface, what will be deflection? That is converted into the Newton by into multiplying by 10. That is basically. So we need to upload the model, and basically that is the results. I can even show you that.